Hi everyone, my name is Lev. In this talk we will talk about React Native. We will start from explaining why companies and big companies such as Facebook, Microsoft, Skyscanner and also Wix picked React Native to develop their mobile application. After that, we will explain the basic concept of the current architecture of React Native, and we will point some of the performance problems that we have in the current architecture, and how React Native is going to solve these issues in the new React Native architecture. So let's start. My name is Lev, I'm Guildmaster in the Mobile Guild, and my background is Android, and mostly we are working on the one-app application. I'm sure everyone here knows what is the one-app application, but for those who just joined Wix, with one-app application, our users can manage their site on the go, but not only, they can also create a digital place and manage a community of members and communicate with them, but the members can also create a digital place and become Wix users. And in such way, we drastically can increase the number of Wix users. Also for users that don't have a website. So we can expose Wix services to users without a website. So let's start. Looking on the native mobile development world, a company that wants to target to the three major front-end frameworks need to maintain three different teams with different expertise in each team. They will have an Android team with people who are experts in Java, Android SDK, maybe Kotlin. They will have iOS people in the iOS team who are experts in Objective-C and the CocoaPods, iOS SDK. And they will have web developers who are in the web team, who are experts in JavaScript, HTML, React, Angular. And there is two major problems in this model. First of all these three teams implement the same business logic, but they cannot share the code between the teams. And second problem is that they cannot share resources between the team, meaning we cannot let Android developer to implement an iOS application. It's very, very rarely that a good Android developer is also a good iOS developer. So what companies usually do, they compromise. They can compromise on time and money and really maintain three different teams. They can compromise on one of the platforms and first develop for iOS, like a lot of startups doing, or vice versa for Android, and then catch up with the second framework. Or just develop for web and after that develop the mobile. Or they can compromise on the quality and work with web view-based solution like Cordova, PhoneGap, and the quality of these solutions are not good because they are trying to simulate the native views of Android and iOS with web elements, and it just doesn't work. So about 4 or 5 years ago, Facebook understood this problem, and they decided to invest in a cross-platform framework called React Native. They understood that they cannot scale in mobile with a native development. And Wix joined that journey too because of the same reasons. Let's try to understand what is React Native. In one sentence, React Native enables us to build application with JavaScript and React, targeting different multiple platforms, but still using the native UI building blocks, meaning we will use the native views coming from the Android SDK or the iOS SDK. Let's take an example. We have a simple application with a button and a text. On the left side, we see regular code that you are familiar from React, but the tags are a bit different from React, from the web React. And eventually our image will be rendered by the class that is extended from the native image view coming from the Android SDK. The same is with iOS. Let's see how does it work. So this is the React Native framework. There are lots of stuff, let's break it. We can break it to two layers. First layer is implemented in native on the Android side with Java, and on the iOS side with Objective-C. This layer consists mostly from native models that are communicate with the Android SDK or with the iOS SDK. And they supposed to implement some native functionality. For example, if we want to save something in the persistent storage of the mobile phone, we will use native model that is saving something to the SQLite database inside the mobile phone. Above this layer, we have the JavaScript layer. This layer is exposing a unified API to the React Native developer. So our business logic of the React Native code is above this API. And there is a thin C++ layer connecting between these two runtimes environments, the native Java and Objective-C and the JavaScript. React Native out of the box not covers all the native capabilities, not covers all the native SDK. But React Native is an extendable framework. We can add our own native models and expose JavaScript API, so React Native developer will be able to invoke this API. Let's see how it works during installation and runtime. So our native code compiled into binary files, the Java and the C++, like in any normal native application. Our JavaScript is bundled with a Metro bundle. Maybe if you're coming for web, you are familiar with the Webpack. It's the same thing, but it's adjusted to the React Native needs. And eventually, we will have a big JavaScript, usually one big JavaScript file, minified and optimized for the target platform. All this packed inside to the APK, the executable file in Android. In this talk, I will mostly talk about Android because it's more interesting and there are more performance problems in Android. And I'm coming from Android, it's easy for me. And when we install and run the application, the JavaScript part will run on the JavaScript virtual machine, and the native code will run on the native part of the OS, like any normal native application. Between these two parts, there is a React Native bridge, which is responsible to pass messages between the two sides. Let's understand what is the bridge in the current architecture. So we have the native side, which is mostly the UI thread, the main thread of the application, which is responsible for the UI interactions, the user interactions, and render UI elements on the screen. But there are also some background threads that we are not going to talk about them in this talk. And on the other side, we have the JavaScript that it's run in single thread inside a JavaScript core. It's a virtual machine. It's a JavaScript engine by Apple. And between them, as we said, we have React Native Bridge, which is actually JSON messages with some instructions that are passing between the two realms. And each instruction is actually what method to invoke on the other side with some parameters. Let's take an example. Suppose we have a button and we are clicking on the button. This, of course, be on the native side because it's a user interaction. This will invoke a message that will be transferred to the JavaScript side. And on the JavaScript is our business logic. And in the business logic, we're supposed to understand what will be invoked next. So our next function will be on button press. After that will be invoked, we will change the state. We want to change the image, for example. So we'll set the new state. This will invoke the render method. And the render method will return a new representation of the UI. The new representation of the UI will go back to the native side because we need to render this. And it's go back, and on the native side, we will update the image. It seems simple, and it actually works. Let's see what we get from this architecture. First of all, we really can share code between Android and iOS. And in Wix, we are sharing about 70% of the code. We can also share some code with web. some not UI related code, like for example SDK. We can share a development power between the teams, where first of all we are building the application both to Android and iOS, but we can also easily take a React developer from the web team, and with short onboarding, he can write to mobile application. We have the fact that our business logic is in JavaScript. We don't need recompile every time the native code. So our development cycles are very short. We are working like in web. We're just changing the code, refresh the simulator, and we get the new code. And also, because the business logic is in JavaScript, we can use instant over-the-air distribution, meaning we can push our code to production by passing the Apple Store and the Google Play Store. We are not doing this at Wix, but it's possible. And maybe the most important thing, now we are working in product-oriented teams instead of platform-aware teams. And this is very important for scaling and development velocity. But everything comes with a cost. First problem, the bridge is asynchronous. And the data that is transferred on the bridge is huge. For example, this is the data that is transferred on the single click. There is a lot of data. It's sometimes batched to a single message, but still the traffic is very high-loaded. Let's take an example of a simple text input that you are all familiar from your dialer in the phone. We want to add a dash after the third digit. We want the user to enter some digit and automatically add the dash. And this is how it will be implemented in native. For example, in Android, this will be a code. If our length is 4, add a dash after the third digit. On native, this code will be executed on the main thread before the fourth digit will be displayed, rendered on the screen. And as a result, we are getting the familiar result like this. Let's see an example how it may work in React Native. You saw this little jump. It's not a little here because I really spammed the bridge and spammed a bit the JavaScript thread, but this is happening. Let's try to understand and analyze what actually happens here. So we press first the 0, and we render the 0 number inside the input text. We send a message to the JavaScript thread. Our onChangeText method is invoked. We are setting a new state with text 0, and it's back to the main thread for rendering. The same will be with the digit 5. The same will be with digit 4. What will happen with digit 6 is that we will send the onChangeText, but meanwhile we will render the number 6 on the screen because our main thread and the JavaScript thread are decoupled. So in some situation, it's very good that our main thread is free to render stuff on the screen and interact with the user. But in some cases, it's very important to do a business logic on the main thread. For example, here. And in the 7, we will get the result. So eventually, we are getting the right result, but the way to the right result might be laggy. It looks like a minor issue, but as our application grows and we have more and more complicated features, we are seeing this stuff more oftenly. Some few examples from the production. Let's say we have this on the left. We want, it's a text input for credit card, and we want limit the number of digits according to the type of the credit card. So you see, after the 16th digit, I'm clicking number 1, we see the ones, and then it deleted. On the right side, we have classic list view problem in React Native. We are scrolling the list view, where the native side don't know what to render on the screen. It goes to JavaScript, but meanwhile, it displays us blank items, and we see white screens. So let's summarize bridge downsides. First of all, in some cases, as we said, we want synchronously communicate between the realms, between the native and the JavaScript. Next, the bridge traffic is serialized and deserialized and copied, and this is a very time-consuming operations. Next, we have unnecessary jumps between the threads, and this is also time-consuming. So React Native, the guys in Facebook understood this problem, and they decided to redesign how React Native architecture looks like. So for understanding the new architecture, we need a bit understand how the different runtimes are communicating in the React Native framework. So the JavaScript is executed by the JavaScript engine. It's actually a program written in C++, and it translates JavaScript to a machine code that eventually executed on the CPU. And there are many different engines. We have the V8 familiar from Chrome. We have Chakra in the Edge browser. And in iOS, we're using JavaScript core it's part of the operation system. And in React Native, we are also using with the JavaScript core. On iOS, it comes with the operation system. And on Android, we need to bring the JavaScript core together with the React Native framework. Let's look on all the runtimes environments that we have in the React Native framework. So the Java, the Android code, will be executed by the Android runtime, ART, and it will communicate with the C++ through JNI, Java Native Interface. Java Native Interface is part of the JVM, and it's part coming out of the box from Android. And this is the way how to execute Java code outside of Java Virtual Machine. The C++ code and the JavaScript core are communicate with JS context. It's a feature inside the JavaScript core that enables to JavaScript code to communicate with the host machine, with the other code in the host machine. And three of these runtime environments will eventually send the instruction to the CPU. Let's look on example of how the C++ code communicate with the JavaScript code. So let's say we have some CPP file, and we have a function device get type that it is a native function that we want to execute from a JavaScript. So we will take the runtime environment and we'll set a property on the global. We will set an ID get device type. I can do like this, and register it on this method. On the JavaScript side, we can just take the global and assign this global to the device type getter. And when we invoke the device type getter, we're actually invoking a C++ method from the native. And we are actually already using this type of communication. For example, when we are doing console log in JavaScript, this is what happens. It's not going over the bridge. Also, the bridge itself built on the same concept of communication through the global JS context. So in the new architecture, we will have the JSI, JavaScript Interface. It's a new way of communication between JavaScript and the native code, the Java and the Objective-C. Let's try to understand what does it mean. The Java and the Objective-C objects and method will be exposed to JavaScript through C++ object called host objects. And JavaScript will hold a reference to these host objects, and through this reference will be able to access methods and properties directly on the native side. This can be done synchronously on the same thread, or asynchronously by invoking the method, creating a new thread, and going back to the JavaScript. Let's look on an example how it's going to be. So on the right side, we have Java code, a Java class, sample model with one method, do something in native, that eventually will print something in the console log. On the left side, we have JavaScript code that want to invoke this method eventually. So first, we need to bind the native code to the JavaScript, to the global and to the JavaScript context. So we will set a property on the global, and the property will be actually a host object that will represent the sample model. And this will bind the JavaScript code with the Java code. When we will invoke the sample model, do something in native, we will actually invoke the get method that will, and we will pass as argument the property that we want to invoke, the name of the method. And eventually, we will call the native code through the JNI. It seems very clear, and it's now a bit weird why we used the bridge at all. In addition, just a second, yeah. All this area looks a bit generic, meaning we can generate this code during the build time, because we don't want our developers who are implementing native models to implement C++ code. So we will be able to define an API in JavaScript, and with an external tool that's called CodeGen, that will be part of React Native, we will be able to generate this binding code. And the native models, the new native models that will replace the current native models that are using the bridge, will be called turbo models, and they will work exactly like this. So if now we have async React Native bridge, we will have async and sync communication between native and the JavaScript. And the JSI also is built in a decoupled way from the JavaScript core. So it's an abstract layer between the engine that executing the JavaScript code and the native code. And we will be able to replace the JavaScript core with other different engines, such as V8 or maybe Chakra, and check what will be better in performance and use one of them. So what we get from the JSI? First of all, no more JSON serialization and deserialization on every call between Java and JavaScript. Second, we will have the turbo models that are defined from JavaScript and not from native, instead of the regular native models. Then we can execute JavaScript code directly on the main thread when needed. We will reduce the jumps between the threads, and we will decouple the React Native architecture from the engine that we are executing with it, the JavaScript code. And another thing that it's now very easy to create a native model written in C++ in a cross-platform way. For example, if we want to use some C++ library like FFmpeg or OpenCV, it will be really, really easy to do. Second problem that we have in React Native is the startup time. You know, when you open, for example, a good application like WhatsApp, it's almost immediate. You see the application on the screen. There is less than a second of a white screen. And this is the result that we want to achieve. So in React Native, we had a problem with the startup time. And we had splash screens. And for example, in one app application, we have about 8 seconds of splash screen, maybe even more on some devices. And there are two main bottlenecks and two main time-consuming operations that happens during the startup of the application. The first of them is we need to load all the JavaScript code and parse it inside the JavaScript core. The JavaScript code is, as I said before, it's a JavaScript bundle that we need to send to the JavaScript core, parse, and execute. We can use different type of JavaScript bundle, and we are already using it in one app application called the RAM bundle. That will, this is actually a minified bundle, a startup bundle with the JavaScript code that we need for the initiation of the application. So it's the startup code and few models that we need to the first screen, let's say like that. And it will send to the JavaScript core. Next, we can fetch the other models by demand, only when they are really needed. And in such way, we reduce drastically the amount of time that we need to load and parse the JavaScript code. This will work only if we will require the JavaScript models in an inline way, meaning inside the function that actually using this model and not in the top of the class. The second thing that is time-consuming during startup is the initialization of the native model. The initialization of the native models happens during the startup of the application because the JavaScript realm is not aware of what type of native models we have in the native, because we can add some custom native models. And what happens during startup is that we really create the objects of the native models, and with the reflection we parse them and create a configuration file that defines what type of native models we have and what types of method each native model has, and this is all sent to the JavaScript. As we said, with the native models that are in the new architecture that are called turbo models, the JavaScript aware of what kind of native models we have during the compile time. So we don't need to create this configuration file. And we don't need to start to create these native models on the startup. And actually, we can already use the turbo models and load our native code lazily. All we just need to do is to change the implementation of the package to extend from turbo React package and implement two very simple methods inside this package. And we will initiate the native model only on demand. What else we have in the new architecture? So in this talk, we didn't talk about how layering works in React Native, because it's a huge topic and it's very complicated. Because in JavaScript, we're defining our layout with Flexbox, and Android is not, or iOS, they have their own type of XML layouting, and we need somehow to translate this Flexbox to the Android and the iOS languages. But the new thing in the architecture that we will have is we will be able to prioritize what UI elements we want to render on the screen. For example, for animation, we want to give a higher priority than a text input, because we want a smooth animation. So with JSI, we will be able to prioritize this. Another thing that the React Native team are working on is to make the React Native core framework more maintainable and lighter. They want to remove some of the native models that are inside the core React Native and move them to the open source repo. For example, the web view, because most of the applications don't need the web view, but each time we have but each time they use React Native, they actually load the web view native model and load all the JavaScript code of the web view. So in such way, React Native will be much smaller and much lighter and easier for maintain. And actually, it's already happened, and in the last version of React Native, they deprecated some of the native models and moved them to the open source repos. So the current state of the architecture and the redesign is that JSI is already in master. If you open the master code and look for JSI, you will see a lot of JSI code. But it still works with threads, and it's still using the bridge. So it's a bit work in progress. Turbo models and Fabric is also work in progress, but we can use turbo models for lazy loading. We already can create a cross-platform C++ models, and it's pretty cool. And as I said in the last React Native version, some of the native models were deprecated. According to Facebook, all these changes supposed to be backward compatible from the point of view of JavaScript code, but not from the point of view of native models. So we will probably have to adjust our code to the new architecture. In general, there are lots of serious companies that are starting to work with React Native and with cross-platform solutions. And it's very good because it pushes the frameworks to be better and not compromise on the performance. Because the expectation of big companies such as Skyscanner or Wix or Skype are much higher than some startups that want to do a POC. And this is what pushes the frameworks forward. That's all.